Okay, good morning, everyone. So, in this lecture, we will be continuing with the last topic that we were discussing. It was this continuous bag of words method. And in that lecture, we have already discussed that continuous bag of words works in a way such that, for example, this is my part of the sentence on which I want to focus. I want to predict the center word from my surrounding words. So based on that, we can make our x comma y like this, that my surrounding word is experience, so the center word is my, obviously in the first case, and then my and with are my surrounding words, experience is my predicted word. So in that way, we have already discussed last time that x comma y will be like this. Then we also discussed that this is how the matrix will look like, followed by the one hot encoding that I discussed in the end. The last thing was this only, that uh, actually all the words will have a embedding. This is the embedding of the first word bean. So when bean has to be used, this one and followed by 6 zeros will be the input, right? And based on that, we can use the one hot encoding. So now, continuing from there, let's say that I want to train my continuous bag of words model using the shallow neural network. And shallow neural network means that we have only one hidden layer. So this is my one hidden layer, right? That's why this is shallow. If we have more than one hidden layer, let's say two or more, then it will be a deep neural network. So shallow means one hidden layer. Okay. So considering we have one hot encodings, for example, this is one hot encoding one, and this is my another one hot encoding. And obviously we had two words, right? We have, let's say, with, and we have has. And these are the two surrounding words. With Thapar has was the sentence on which I want to focus. So let's say that these are my surrounding words, and this is the predicted word that I want to focus on. So with will be my x1, and it will be 1 cross 7 vector. Similarly, this is my x2, and my vector will be again 1 comma 7. And let's say we take the values from that one hot encoding matrix. So this width will be like this. For example, it was like this. And then similarly, has will be something like this. You can match it with the previous slide later on. So this is the input, right? And then these are the weight matrices, 7 cross 3, 7 cross 3 in both the cases, and both of them are first weight only, weight 1. So we are actually putting all the things in this smaller embedding. We are calculating the activation matrix here, and this will be uh, now this is 1 cross 3, right? So this is 1 cross 3, and based on that you will be getting the output of 3 cross 7. So for example, my predictions are like this, just for the sake of argument, because we want to say Thapar is the output. So Thapar was, uh, let's say we will also make the actual output here. So this is the actual one hot encoding of Thapar. For example, like this, 3 4 5 6 0 0. So let's say this is the one hot encoding of Thapar. So we will assume that because we are using the softmax activation function, we want that the maximum weightage should be at this place, right? This should be interlinked. Then only our model is well trained. So for example, all the outputs in the softmax are like this: 0 0.03, 4, let's say it'd be 1. So 7 plus 2, 9. Okay, so let's give this 0 0.88, and then 0 0.03. So like this, let's say we have the outputs. So this is my output layer having all these values, and softmax, we all know that softmax will take the maximum value out of it, and that will be the output. So we also want, now till now we have only discussed the forward pass. Let's say for the backward pass, or we can say back propagation, we have to match these two. And for back propagation, we will be propagation, we will be actually focusing on the updations of update your W1 and W2 accordingly over time, over the number of epochs, right? Because we want that this kind of output should come. So this is kind of the output only if we have well trained model. Otherwise the values will be hodgepodge, and it will not be good enough to be giving the output of the this thing, the Thapar one hot encoding vector. And we also want to look into the uh, outputs, that how they are being calculated. So the one hot encoding of the inputs flow through the network in the forward pass in this manner. So what we do is, because we had two things, we had two words, we had with and has, those were the two words. So for the with x1 comma w1 and similarly x2 comma w2 divide by 2, this will be the output of the hidden layer, right? And the output will be in the form of 1 cross 3. Similarly, output of the final layer, that is my output layer, will be calculated like this: f and this value of L1 out comma W2. So W2 was 3 cross 7, L1 out was 1 cross 3, right? So it is written here. So output will be final 1 cross 7. Here f is my softmax function, right? So I hope we all know that how these things work. The basic understanding is this. So the takeaway is that we are taking the average of these values when we have multiple words. Here the context size was only one, so we were only looking at the one neighboring words on the left hand side and the right hand side. So based on that we have to take the decision. So this is the way. Then let's move to the next slide. So weight matrices for learning the context. So now I want to focus that it's not just that we want to predict the value through the softmax, that which one will be the output, but we also want to focus on the embedding, what kind of embedding it is generating. So 3 cross 7 was the uh, weight matrix, right? So this is the weight matrix 3 cross 7, and so actually this is 7 cross 3, so there are 7 rows and 3 columns. So this is 7 cross 3, let it be w1, right? So this is what we saw earlier also. W1 was 7 cross 3, 7 rows and 3 columns. So this is w1, let it be. Okay, word embeddings are stored in the weight matrices, and we have considered w1 as the embedding matrix. And we all know, we have seen earlier that one hot encoding of the Thapar, that uh, Thapar is 0000100. So we could see here the sentence was, my experience with Thapar has been successful. So the fourth word is Thapar here. So similarly, we have also, I mean, there is some mistake here. Obviously this one will come at this place. Okay. So but the context is that only that we have to match the word accordingly, according to the place where the word is in the sentence. So let's say it is triple zero one triple zero, based on the word was at the fourth place. So the weight matrix of the hidden layer is like this. So this is the W1, and we know that the Thapar is having this kind of word embedding. So these are the three values that are corresponding to the word Thapar. Then every row in the weight matrix W1 is a word embedding. And rather than multiplying the one hot encoding by the weight matrix, we can directly pick the row according to the position of one in the OHE, one hot encoding, and use W1 as a lookup matrix. So the word embedding of word not only captures the meaning of the word, but also reduces the dimension. So that's what I was talking about, that initially we have seven values, but in the center we have that hidden layer having only 3 neurons. So we are actually reducing the dimension of the word vector also. So here that's what is written, that initially one hot encoding was 7, and then which was reduced to 3 in the word embedding. Let's talk about the skip gram also. Now let's say, obviously we know that predict the surrounding words given the target word. So what happens in the skip gram is, we have only this as the input, and we have to predict the surrounding words. So all that is not gold are the surrounding words. You have to predict that given only one single word. So this is how the things should be. And in this means that this will have some one hot encoding vector. So let's say there are total 6 words. Okay. So let's say this is my 100 encoding vector of this one, 001 000. So this will be the input, and output will be depending on the how many predictions you want. Okay, so let's look into it. Just a second. Yeah. So now same thing here, but the takeaway is that we want to predict the surrounding words. So given the word experience, we want to give the output as my, or given the input as my and with, we want to give the output as experience. So or we can say given the word experience, we want to give the output as my comma with. So obviously x comma y has to be this. So let's say given the word with, we want to say the output as experience and Thapar. Given the word Thapar, we have to predict with and has. So I hope you understand what's happening here. Then that has been segregated into x and y columns. So my experience with Thapar, all these singular words are the x part now, and the prediction is the surrounding words: experience, my, with, experience, Thapar. So all these are the output words. So you have to predict all these. So similarly, I mean the architecture will be nearly same. Let's discuss the architecture directly. Uh, so okay, so that's what is written here. What we have is we have nearly same architecture of the skipgram. I will make it somewhere. Let's say I will draw it here only. So similar to what we had in the uh, continuous bag of words method, we have a similar kind of diagram here. For example, just a second. Yeah. So this will be the input. So let's say this is my input, and Thapar is the input. So let it be. We will say that we will use the same sentence that we were using previously. So this is my x part, where Thapar was like this. Let's say this was the input. This was the initial one hot encoding vector for it. Then the weights will be transferred. Weights will be actually used to predict this thing, hidden layer 3 neurons. So after these 3 neurons, we will be actually having the values like this. For example, we have this as the output: 4, 5, 6, 7. Okay, so let's say we have these values: 0 0.002, 0 0.003, 0 0.497, 0 0.002 again, 0 0.002, 0 0.493, and 0 0.001. So let it be the output, right? So obviously we have two values here which are having high numbers, others are very low numbers. So we know that we have two outputs here, but how to segregate this? We will be actually using the softmax only to get the output, but having the top two values instead of top one. So top two values will be taken as the output. So generally it gives the maximum value. It generally takes the only maximum value and give the output. But here we will be using top two values. So top two will give me the output as, so the first one will be the vector like this, where we will have this thing 001 0000. So this is one output, and the other output was like this: 00 00010. So these are the two words that we want to predict, and let it be this second one be the with word, and this one be the has word. So my experience with Thapar has been wonderful. So these two words will be given as the output using this method, that we will be using the softmax only to get the output in the weight mat after the calculation of weight matrix 1 and 2. So using the weight matrix 2, you will get something like this after good amount of training. So because these two are the top two highest values, so these two will be the one hot encoding outputs depending on the prediction of the softmax. So this is how the skipgram has to work. Now because we are only taking the context size of one, and we are only taking the surrounding one word only, so that's why we have two outputs here. So if we had four outputs, then we could have taken top four. So let's say that we wanted to predict two surrounding words: all that and is not. and the input word is glitter. So total four outputs would have been there, and then we would have taken top four values instead of top two, because two on the left hand side, two on the right hand side. So based on that, the output would have been taken. So continuing from this place, uh, okay. So now we all know the architecture of the skipgram is the same as the continuous bag of words, and we have one hidden layer. The input and the output layer both have the 7 neurons only. This is equal to the size of vocabulary. So obviously, depending on the size of vocabulary, we will keep that. The hidden layer has a activation linear function, and whereas the output layer has the this softmax activation function, and depending on that, you will get the output. So continuing from here, the difference is this: the in the final output of the first layer is this one. So for the continuous bag of words, we are talking about the first layer. We were taking the average of two words because there were two inputs. Instead, here we have only one input. We have only one word. So in skipgram, x1 comma w1 is enough instead of taking the average. Now let's move to the last topic of our syllabus, topic modeling. It's part of semantic uh, NLP only. So let's say that you are the product manager, and we want to look into the customer reviews, and we want to identify that 50% of the customers are talking about the hardware of a product, then 30% are talking about the features of related to the music, and 20% are discussing about the packaging of the product. So this kind of information can only be extracted if we want to if we are working on a topic modeling thing. um, it just means that, let's say we have 100 customer reviews, and we are classifying each customer review based on that what is the main topic that person is talking about. So let's say that the first one is talking about the hardware, so we will assign the topic as hardware to that first review. The second review is talking about, let's say, music, so this will be one of the topic, and the third one, let it be as the packaging. So depending on these three classifications, we want to classify all the customer reviews. So this is the actual goal. And similarly, also imagine that if you have multiple research papers, the scientific documents, and you want to generate a search engine depending on that which keyword is actually matching, or we can say that, or what kind of topic the research paper is talking about. So is it about diabetes, is it about cardiac arrest, is it about obesity? So all these kind of topics can only be extracted through this topic modeling, and this is actually used to extract the topics from the corpus of a text, and that's written in the bottom. Then uh so let's take this example. For example, we have this topic one, we have the keywords of model, data, validation, neural network, supervised machine learning. So these are the topics for our first uh, I mean, this is the first topic cluster. So if any document is having these keywords, we will say that it is referring to topic one. And then topic two has these keywords: cancer, hospital, medicine, x-ray, disease. So this is about healthcare. The third one, let it be about the food and beverages. So chef, restaurant, chocolate, spicy food, etc. So let it be about the food and restaurants. So let that be the topic. So we have made these three topic clusters, and for example, document one comes in front of you, and it's written machine learning can aid and improve early detection of breast cancer. So now we all know that here are machine learning and cancer. These are the two words. So obviously machine learning is part of topic one, and cancer is part of topic two, right? So we will use this, we will use these as the matching keywords for matching the topic. So we will say document one is talking about the topic one and topic two. This is the heading, right? Topic one and topic two both are being talked about in this document. Then let's say this is the sentence: the benefits of machine learning in the restaurant industry extends beyond the robots taking the orders, making and delivering the food. So these are few keywords that have come up: restaurant, food, machine learning. So based on this, we can say that our topic document 2 is talking about the topic 1 and topic 3. So topic 1, let it be, AI. So let's say the first topic is artificial intelligence. The second topic, let it be healthcare. And the third topic can be, let's say, uh, food, right? So what we will do is we will assign these keywords to our document. So at the end of it, we will say that AI and healthcare are the two topics that are being talked about. So that's what I meant in the previous slide also, when we were saying that we will be assigning some keywords or the topics to that document, whatever kind of the document is. Here we will say that this is relating to AI and food, right? So we are assigning the keywords, we are assigning the topics to that document. Okay, so moving ahead. So there are multiple types of algorithms we can use in topic modeling, and the most famous one is the first one, non-negative matrix factorization. So we will look into the details of it, we will understand that how it works, and we will also look into the code. We have a coding exercise in the end. uh, we will be implementing this NMF method. This is NMF, and we will be implementing it on the IMDb reviews, and we will predict that what kind of movie it is or TV series it is, what is the theme of it. So we will be working on that kind of a data set in the code. So let's talk about NMF. So NMF is, this is how it works. It approximates a matrix X as a product of two matrices W and H. So given the original matrix X, we will try to get these two matrices, we will approximate them, where we will say that both of them are having the value of greater than equal to 0, and we will also see to it that our WH dot product is actually getting the value near to X, the original matrix. And this is done by minimizing the square difference between the X and W star, W into H, not the W star, but W into H, also known as the Frobius norm. And this is the optimization problem, as the equation tries to get close to the minimum value as as much as possible. Okay, so moving to the next slide. Just a second, I will bring the laser pointer. So let's talk more about it. To calculate the Frobenius norm, we will calculate the sum of square of the values of the XWH matrix. The formula for calculating the Frobenius norm of the matrix A is as follows. So this is the formula which we have to uh, take care. The dimension of W and H will depend on the number of topics. Depending on the number of topics, we will have this. The original matrix S is of the size number of documents. So here my X is of the size number of documents into number of terms. So we are dividing that into these two parts, and our W will be equal to number of documents into number of topics, and H is of the size number of topics into number of terms. So this is the basic uh, understanding about the topic of this NMF. And I have this diagram also. Yeah, this one. So this is how it works, that let's say I will draw it again on the slide, just a second. So let's understand that in more detail. So let's say that the document, we all know that document term matrix can be factorized into document topic matrix, which we will say that this is my output 1 multiplied by, so because this is the factorization, so we will use multiplied by this thing, topic term matrix. So let's say this is my output 2, right? And we can visualize it as, let's say that this is my initial document term input. So this is my document term as input, having the dimension of D into T. and this will be like this. So this is my WD into 4. Let it be number of topics be 4. So I will write here number of topics. We are assuming to be 4. So document topic matrix, right? So this is my output mat 1. This is my output 1, and this the dimension is D into 4 multiplied by the topic term matrix. So topic term, and this is my output 2, right? So dimension will be H4 into T. So this is how it looks like. This is how the NMF works. We have document term matrix equal to these two outputs ka multiplication, right? And this is how it looks like. So this is the actual thing. Let's take the example. So for example, we have few things in front of us. Let them be these 4 TV series. All of them are TV series: Big Bang Theory, Game of Thrones, The Office, and Breaking Bad. And let's assume that we have this thing. We have the keywords such as scientist, sarcasm, kingdom, laughing dragon, politics, suspense. So depending on whatever the topic is, we have given some numbers. For example, Big Bang Theory has scientists, and it is also funny, and we have given some number to laughing. So these are the two keywords on which we can say that okay, Big Bang Theory refers to something when we have uh, topics as scientist or laughing. Game of Thrones has been uh, highlighted where we have kingdom or the dragon and even the politics. The Office is sarcastic. It is comedy, right? So laughing and sarcasm is there, and some amount of politics is also there. The Office politics. Then the Breaking Bad is something where the scientist is working to generate some uh, chemistry based compound. So this is 0.29 value given to the scientist part, and suspense 18%, politics 10%. So we have given some numbers, right? And this is how it looks like. This is the input. This is my X, and we want to break this into two matrices: the document topic matrix and the term topic term matrix. So these are the two matrices that I want to bring out of it. So let's say that, let's continue to the next slide. So let's say the document topic matrix has these kind of values. So we have the number of documents. All the documents will be in one line here, right? So we will have all the documents in the column: the Big Bang Theory, Game of Thrones, The Office, Breaking Bad. And we have multiple topics because this is document topic matrix. So we have multiple topics. Let's assume that there are a few topics that we have highlighted. We will name them later on, but these are the 4 topics, and based on that we have taken these are numbers. So Big Bang Theory has topic 1 49% and topic 2 29%. Similarly, Game of Thrones have these two values as a high number. The Office has this number as high, and the fourth one is having these two numbers as the high. So depending on the document, we are able to say that okay, this document is referring to this kind of a topic. So this is how we have the document topic matrix. Then topic term matrix can also be generated depending on the topics: topic 1, topic 2, topic 3, topic 4. We have given some numbers to the keywords, the terms on which we want to map the topics. So we have this matrix also. And now obviously, let's say that 51% sarcasm is there, laughing is 41%. So we want to give some number to it, right? And sarcasm and laughing means topic 1 can be comedy. Similarly, topic 2 is having scientist and laughing. So maybe this kind of thing can have sci-fi. So all those names have been written in front of you: comedy, sci-fi, fantasy, and thriller. So be very sure that this is actually the uh, unsupervised technique, and we will have to give the names on our own. So comedy, sci-fi, these are not given in some input, or we don't have them as the labels with us. We are assuming depending on whatever the terms we are actually utilizing. So this is all in our imagination. Depending on the keyword, I mean, depending on the understanding you have, you can give some names, and all of this is in a unsupervised manner. So this is how it looks like. The Big Bang Theory has comedy and sci-fi. Similarly, the Game of Thrones have sci-fi, fantasy, and thriller. The Office has 54% comedy, and that's it. Breaking Bad has sci-fi and thriller into it. So we have actually mapped both the things, right? This is the output one for document topic, and depending on that, you can also we also had seen the topic term matrix. So these are the few things. uh, to see the summary, topics are not necessarily coherent, self-contained, or meaningful ideas or the concepts. And topics are bag of words. We have actually bag of words only, topic one, topic two, right? Then topics are a distribution over the whole vocabulary. Each word in the vocabulary has the importance under a topic. Topics have been given a meaning by looking at the most important words under the distribution. So we have already seen all these things in the previous slides, and we all know now that how this topic modeling works. So we have this decomposition of matrix of x equal to w into h, where the one matrix was the document topic matrix and the other was topic term matrix. So these were the two outputs, output 2 and output 1, and that's the summary. Now let's look at the final code, and then we will wrap up the session. I will take 4 to 5 minutes to discuss this code. Just a second, taking you to the coding window. So just a second, yeah. So let's say we have already, I mean, I've already made this code for you, and I will prove it to you that how it works. We will look at some output that will be given, and we will verify it on our end that, okay, this is fine. So I don't want to change this code because it is already put on my GitHub. So I will discuss directly the GitHub code. Okay, so inferring topics from the IMDb reviews. So we will use some inputs. So these are the some importing things that we need. Import the numpy, import os for handling the file handling part, and then sklearn will be used to get the tf-idf vectorizer. So we will be filling that matrix using this tf-idf. Then we also want to use this non-negative matrix factorization, so we are importing that. Then we have the plotting and pandas. So these things have been imported. Now this is the data set. If you click on it, you will be taken to a page where you will be given a tar file as the uh, there will be a zip file that you will be able to download, and within that we will try to find the only positive things, only the positive tweets out of it, right? So this is the positive tweets of the movie, or the review. It's more about the review and not the tweets, because there are very large reviews also, the paragraphs. So this is the review, and this is being downloaded from this link. You can check it on your end also. Plus I have also put this pus.zip file in my GitHub only. So if you go to this thing, I will open it in a new window. Just a second. So if we look here, you will find pus.zip file here, right? So in this repository of rapids mlds, you will find the pus.zip files. You can download it from here and you can use it in your code. So coming to this code, coming back to it, so we are unzipping it, and we are actually putting, we will be using the pus files only. So once we also want to now generate that how many reviews are there, how many total reviews are there. So we will use this code. You will use this os.list directory, and then we will join that with the file name, right? So we will read all the reviews and we will count them. So length of reviews is 12,500. Now if I want to look into the only first three reviews, so this is how we can see. So this is my first review, this is the first review, this is the second one, and this is the third one. So total three reviews are there, and depending on our understanding or our code NMF, it will help us to classify this into some genre. It may be thriller, it may be sci-fi. So all those kind of things we will look into. So now we have these kind of reviews, they are long and we want to generate the topic modeling for them. So now first we will be removing the stop words from the English dictionary. We will be taking help and we will be removing the stop words and generate the TF vectorizer, TF idea vectorizer. Now x equal to fit transform reviews, and we want to convert it into the array and get the feature names. So all the feature names have been named as the columns. So we will see, if you print that, you will see that total 12,500 rows are there. Those are the number of documents, and 55,000 columns are there because there are other languages also. So it's not the English only. So there are multiple languages. There are other kind of keywords also, and there are some numbers also in the beginning. So those kind detailed TF-IDF vectorizer has been made out of it. Now we want to utilize it. So what we will do is we will decompose that matrix into two parts, the W and the H, right? So document topic matrix and the topic term matrix. So this can only be done. Let's say we want to say that, okay, we have total of 15 topics that we want to classify, and NMF number of components is 15 now, and so NMF fit transform X will help me to get the document topic matrix. NMF dot components underscore will give me the topic term matrix. So let's say that we want to look into that, okay, uh, how it looks like, how is this topic words looking for us. So here we have only taken 10. Yeah, so because we are actually getting the values like this, there are total 10 words. Just a second. So we are taking only 10 words here. I think it should have been 10 words are fine. So because based on 10 words only, we are classifying that into 15 topics. So there are total 10 words based on which we want to get the work done. So this is how we are getting the topic words being generated. And depending on the top 10 words, we want to classify that into the 15 topics that we have shortlisted. Now you can see, let's assume this one, the topic 15. We can see that it is talking about some fighting skills, kung fu and martial arts, right? So let the topic 15 be the martial arts. And topic, there are other topics also, I have already done it for you. So topic 4 is having TV related things, so series, episode, TV characters, track, season, shows, new, right? So all these keywords are from the topic 4 relating to TV. So topic 7 is relating to the war, so life, people, family, world, real war, way, lives. So all these things are, I have taken it as a war, that this is the war related topic. Then topic 8 is comedy, funny, comedy, laugh, right? So this kind of dictionary you can also generate, create a topic mapping like this. So you can work on a different data set, you can make different kinds of names. So this is all generated by me only, TV or war or comedy, whatever it is. So you can change these names depending on what kind of classification you want. And one thing to be taken care of is not all the topics are making sense. So for the first one, BR10 LL spoilers and simply yes. So this is noise for us, right? So this is not being classified into a good topic. Even I cannot say that this is something related to maybe horror or anything like that. So topic one is noise for us. So we are skipping that. So it depends all on us because this is unsupervised training types algorithm. So W equal to PD dot data frame, and this will get me the document topic matrix. So this is how the values are. So if I want to get all the values, so we can generate it like this, and for different topics we are actually getting the output as what is the topic here. So martial arts is being classified, martial arts and action for the first one, horror for this document number 10, comedy for document number 16, 25 document is being classified as book adaptation. So let's say like Harry Potter movie is made out of the book, right? So that's a movie out of a book. So that's book adaptation. Then horror EV. So these are the different topics that have been given as the output for these particular topics. And I have actually tested it for you as document number 16 is giving me the output as these things. So this is my 16th document, that is the review. And we have something laughed. So there are multiple things. uh, Laugh is being used again and again, right? So, and also it is saying that this film is one of the best pseudo documentaries to come along, including A Mighty Wind. So we don't know the movie name out of this comment, but we do know that the person is saying that this all of this movie is similar to a Mighty Wind movie. So I checked it on Google that what is this Mighty Wind. So I found that Mighty Wind is having the genre of comedy only. So 16th document was having comedy as the topic name. So this is how the topic modeling can be done using this NMF technique. And I tried to check others also. Not every topic was being correctly mapped, but this is one of the technique, right? This is the most famous one. So you can check on your end. Maybe it works better for up to 15 up to 20 topics instead of 15. So I have taken only 15 topics. Maybe you can check it till 20 and you can generate some other kind of mapping. So it's totally on you. So you can take the code from here. I will put this code link in the chat box. Just a second. And then you can go ahead with the verification and everything. You can run this code on your end. And you can pick this zip file from here. It's in this repository only, pos.zip. So this is being used in this unit 5 NLP NMF. So this is the code. Here you can find it. Okay, then that's it for today. And this is the end of the syllabus. We are done with this conversational AI data science subject. Till this topic, the syllabus is till the EST. So after MST, till this topic is the syllabus of EST. Prepare well and good luck for exams. That's it. I'm ending the class now. Thank you.